Okay, we are now recording, and if there are no questions, ask that before I turn the recorder on, so hopefully I've gotten whatever answer is going to get there. We're in chapter 10, conics, parametric equations, and polar coordinates. We're not doing the conics part. We'll do whatever we need to in conics, but I'll explain that as we get to them. We're in the parametric equation part now. That's 10.3. And then in 10.4, which we'll probably get to today, will be the polar coordinates part. Which means, of course, we are now through with, or will be through when we finish 10.4, with what we're going to do in chapters 9 and 10. So guess what? It'll be test time again. I know some of you have submitted your tests, and others of you may have done so over the weekend. However, I wasn't able to, Kira, I was telling Houston and Miguel this, or Jesus this, when we got to the farm on Friday, went right to work because I had a lot of mowing to do. So went right to work, but that evening when we came in, the phones went out. That took the internet down. So we had no internet or phones for Friday evening, all day Saturday, and most of the day on Sunday. They came back sometime Sunday afternoon, early evening. And so, oh, here comes somebody. Jemanuel is coming. So let me get him here, if I can get it to admit him. So Jemanuel is here. So if you had sent anything, I couldn't have received it anyway because we were completely cut off. The cord was cut, this weekend, which wasn't bad, but I got very little done of what I wanted to get done. So I've got a lot of catching up to do this week. And I have a feeling it'll be a lot this weekend because I don't have much time this week to get caught up. Okay, so any questions, issues, concerns? All right. As I was saying, we're in chapter 10. 10.3 is parametric equations and calculus. And we are on example 3 on the top of page 712. And here is the problem. The prolyte cycloid x is equal to 2t minus pi sine t, and y is equal to 2 minus pi cosine t. Okay, that forms this cycloid. Now they drew it for you, which thank you very much. I appreciate that. But if we wanted to check a few points, we could do so. Okay, so what we'll do to check those points are just to basically do a triple T table, maybe you would say. And that table, earlier today this pen wouldn't work, and now it is. I don't know why, but we'll do our T, X, and Y, and check a few points here and make sure they got them right. So give me a T. Anybody, give me a T. Anybody? My favorite is 0. Okay. When t is equal to 0, this will be 2 times 0. X will be 2 times 0 minus pi times sine of 0. Well, sine of 0 is 0. 0 minus 0 is 0. So x is going to be a 0. Okay. Y is going to be 2 minus pi times the cosine of 0 is 1. So 2 minus pi, that's going to be something about 1, because pi is 3.14. This will be something about negative 1.14. And that's down here. 1.14 right there. So there's the first point we chose right there. Okay. Oops, I didn't write this in. I'll approximate that to be negative 1.14. 2 minus pi, which would be about that. I'm not going to carry as many digits as probably the book did. Okay, give me another t. Well, how about pi halves? Sounds like a good one. 2 times pi halves would be pi minus pi times the sine of pi halves. Sine of pi halves is 1. So this would be a pi. So that would be pi minus pi. That's a 0. Yo. Okay. How about the cosine? Cosine would be, wherever my pen is. Where did it go? There it is. Okay. 2 minus the cosine of pi halves. Whoa, here comes Laron. Whoops. Laron and James. Okay, let me pause for a moment and get them on the books. Laron is here and James is here. Bottom part of the alphabet is here in force. The top part halfway here. Okay, so we're still missing Esther and Kyle. Okay. Now, welcome the rest of you though. 6 people, I believe that's what I got. Yep, 4 and 2 are 6. Got it. Okay, we're doing example 3. Sorry. Example 3, chapter 10, parametric equations and polar coordinates. 10.3, parametric equations in calculus. And on page 712, example 3, near the top of that page. And by the way, this example is also at larsoncalculus.com. You can see an interactive version of this type of an example. All right, so we're just checking a few of their points here. We were doing this one when t is equal to pi halves, y is 2 minus pi times the cosine of pi halves. Well, cosine of pi halves is 0. So this will be 2. So the y is going to be 2. Okay, well, let's see where we are there. 0 for x, 2 for y. We're right here. So judging from what they've done, I can't tell yet, but from what they indicate, we know we're here. We don't know how we got there. From their arrows, we came around this way. We're going to have to check that and see. Okay? Let's do another t. This time maybe let t equal minus pi halves. Okay? And 2 times minus pi halves would be minus pi minus pi times sine of pi halves. So sine of pi halves is 1, and that would be a minus pi is minus 2 pi. Did I do that right? That would be a minus pi, because 2 times minus pi halves would be a minus pi minus, oh wait, sine of minus pi halves is negative 1, so that's going to be a plus pi, so that's 0 here also. Boy, x can't get off zeros, can they? And when you plug in a negative pi halves here, you get 2 minus, well, cosine of negative pi halves is 0, so that's 2 again. Well, there we are again. We're at this point again. We're there for pi halves and for negative pi halves. We really can't tell which is which. So let's go one more out, like maybe pi. Okay? So t is equal to pi. Okay? This will be, x will be 2 pi minus, and sine of pi is 0, so it's 2 pi. So that's going to be around 6 or so. I'll just put down 2 pi here. Okay. When you put the y in, the t in for the y, 2 minus, well, cosine of pi is negative 1, so that's a negative and negative is positive, so it's 2 plus pi. Okay, well 2 plus pi, the y is going to be about 5.14. Okay. Okay. Well, on x, we're at 2 pi. Here's pi. At 2 pi, we're somewhere out here, and this is up somewhere around 5. So sure enough, we're somewhere, let's see, 2 pi would be about here maybe, and we'd be, yeah, that looks about right, somewhere around there. So this is where it's going in this direction. So obviously here it came from here, it came from here. Let's see if it came from back there. Let's do t equal negative pi. Well, this will be minus 2 pi minus sine of a negative pi would be 0, so that would be a minus 2 pi. So your x is minus 2 pi. That would be out here somewhere. If we could extend the x-axis here, somewhere out around here. This is minus 2 pi. And let's plug in here. Y would be 2 minus cosine of a negative pi. Okay. Cosine starts at 1, so that's be a minus 1. Minus a minus is plus, so that's 2 plus pi, and there we are again at 5.14. So this will be minus 2 pi here and at a 5.14 approximately here. These are approximate numbers here. Okay, and that would be somewhere around here. And sure enough, we seem to be coming in that way, going down this way. So there's our curve. They graphed it right. We didn't have to do that, we just did. They tell us this prolate cycloid, which we just drew, they drew it for us and we just verified it, given by these guys, crosses itself at 0, 2. Okay, now obviously this is not y as a function of x or x as a function of y, because it crosses itself. Can't happen. But both x and y are functions in t. They don't cross themselves. You don't have any lack of functional value there. Okay, now what it says to do, find the equations of both the tangent lines at that point. Now they've drawn in light blue those two tangent lines. Here's one and there's one. Okay, so what are we going to have to do here? We have to determine the tangent line at those 2 points. Now if you remember, and this is on an xy scale, so we need to figure out what dy dx, even though y is not a function of x, it's still a relation of x, but we need to find that out, and we know that is dy dt over dx dt. So we got to figure out what both of those are. Now, I found out this morning just by happenstance how to erase on this slide. All this time I've been saying I can't erase on this slide, and I found out sure enough I can. Okay, I just did. I just flashed back. I'm so tired. By the way, I got up. Y'all probably don't care about this, but I'll let you know. We had to get up this morning about 4:45 Eastern time, which would have been 4:45 Central time. Okay, and that's we're going to bed around, I'm guessing I finally made it to bed around 11 o'clock Eastern time, which would have been about 10 o'clock here, but still that's about 6 hours sleep. You know, no, less than 6 hours sleep. And I feel like it too. And then we've been up and at 'em, loading the car, driving, and getting here since 5:45. I mean, well, we left the house at 5:30. We got up at 4:45, loaded, and left at 5:30. So I'm running low on brain power, okay? If I'm not making any sense, that's why. Just yell something at me and maybe I'll make more sense. But anyway, in my stupor, I went down. I don't know if any of you were in my class when I taught with Tegrity. With Tegrity, we had a band down here, and I went down there, and sure enough, I clicked on it, and it's the same thing as you have here. It's amazing. I've had it all this time and didn't realize it. So let's figure out what dy dt is. Here I'm just going to call it y prime because I don't have room to write all that. Derivative of 2 is 0, and this would be derivative of cosine would be minus sine, so that's going to make it plus pi times the sine of t. Okay, let's do the same thing here and do x prime. This is with respect to t. That will be 2 minus the cosine of pi, pi times cosine, because derivative of sine is cosine t. Okay, and then we want to take the ratio of those, and that's what we have here, and that would be pi times the sine of t over 2 minus pi times the cosine of t. Okay, now here's where things get a little tricky, as if they're not tricky enough already. You have to figure out where you are, Waldo. Here are the points where we are at 0, 2, and this is one reason it's good we did this, because that 1, 0 is when t is equal to pi halves. The other 0 is when it's equal to minus pi halves. So we have to go into here and plug in, doesn't matter which one first, we'll do, I hate to use this terminology here, but I think I will. This y prime is not that y prime. Well, I better do it. Dy dx. I'll keep it like this. Dy dx here is going to be, and this is at t equal, which you want to do first, minus pi halves or pi halves? I don't really care. Anybody? Let's do minus pi halves. Minus pi halves, that derivative would be this thing right here. Pi times the sine of a negative pi halves over 2 minus pi, that's pi, times the cosine of negative pi halves. Okay, now get this one. Sine of negative pi halves is a minus 1. So that one's going to be a minus pi, because sine is minus 1, over 2 minus cosine of negative pi halves is 0, because cosine at the half pi is 0. So that's just going to be 2. So our slope here is going to be minus 2 over pi. Now that's not someone coming in, I don't think. Let me just check to make sure. No, we got 6 people here just like we did before. Okay, now negative pi over 2. That's going to be close to negative 3 halves. A little bit steeper negative than that. That looks like that's the slope of this tangent line. Okay, so this is your m at minus pi halves. Okay, now let's do the same thing for the positive. Dy dx is equal to pi times the sine of pi halves. Okay, that's from here. Oh, this is when t is equal to pi halves. Okay? Divided by 2 minus pi times the cosine pi halves. Okay? Well, sine of pi halves is 1, so that's just going to be a pi up top. And then the bottom cosine of pi halves is 0, so that's just going to be 2. So that would be something a little bit greater than 3 halves. So this is the slope. This is your m when t is pi halves. This is your m when t is negative pi halves. So this is your slope downward, and we said that's the direction it's going there. So that's the slope downward here. Here is the slope upward here. Now, yeah, and that's negative pi halves. Okay. Now, it asks for the equation of the tangent lines at that point. Well, guess what, folks? We have a point on those tangent lines, 0, 2, which happens to be the y-intercept of those two tangent lines. So we can go straight to our slope-intercept formula. So y, and this is going to be t equal minus pi halves, is going to be the slope minus pi halves, that's from down here, times this mx plus b, and your b here is 2. Okay? And the slope, the equation when t is equal to positive pi halves is going to be pi halves. There's just too many pi halves here. Yeah, t is equal to pi halves, but the slope's pi halves too. It's just almost confusing. And this is going to be, where is my pen? Where did you go, pen? There you are. Okay, pi halves x plus 2. Same intercept. Now that's a bit bizarre, but it is indeed true. Now, why in the world they wrote it the way they did, I'm not too sure. They wrote y minus 2 is equal to minus pi halves x, which is what we have here on the top one. Y minus 2 is equal to minus pi halves x, and they wrote y minus 2 is equal to positive pi halves 2x for that one. I don't know why they wrote it that way, but they did. Okay. Any questions on that one? Now that was a bit bizarre because our variables for t happen to be minus pi halves and pi halves, and then the slopes happen to be minus pi halves and pi halves for those same ones, and that made it really a bit bizarre. But don't let it confuse you. They won't always be that way, I promise you. All right. Now, let's see how they did the problem. Maybe we'll see why they came up with that answer. Okay? Because x equals 0 and y is equal to 2, when t is equal to plus or minus pi halves, we found that out. And derivative dy dx, which is dy dt over dx dt, is pi sine t over 2 minus pi cosine t. We also found that out. Excuse me just a minute. This lack of sleep is coming through. Hold on. I'm not sure that'll do much good, but every little bit will help. Sorry. Okay. That was your derivatives here, just like we got. And you have dy dx is equal to minus pi halves when t is minus pi halves. Do not expect that to be the case every time. Bizarre, but true. and dy dx is positive pi halves when t is equal to positive pi halves. Don't expect that always to be the case. This is a rare circumstance that happens to work out that way. All right, somebody is here. Laron must have had to leave and come back. So I'm glad he's coming back. But that gets us up to 7 students. Now 6 students. He must have gone out and come in a different name. Excuse me. A little bit of Coke in the can wasn't sufficient. Now that's a little bit better swig. Now, I think I tried this before. I don't think it works well, but let me try it again. That may keep it a little cooler. All right, sorry about that. So that's how we get the slopes. From there, we have to come up, well, I can't advance. There we go. So the two tangent lines are, now, oh, I know what they did. They did point slope formula. Why in the world would they use point slope formula when it's so much easier to use slope intercept formula? But they use y minus 2 is equal to m, which is minus pi halves times x minus 0. So that gave us that one. And y minus 2 is equal to m, which is pi halves times x minus 0, which is that one. So that's why they turned out doing it backwards. They used point slope formula rather than using slope intercept formula. Slope intercept would have been far easier to do. And a little more standard too. All right, any questions on example 3? All right, moving on to arc length. Okay, so one thing you can do with parametric equations in calculus or calculate slopes and tangent lines just like we're used to doing back when you first learned derivatives. That's what you dealt with, slopes and tangent lines. Here's another, arc length. Now this was much later on before you got to arc length, but let's see what we've got here. The arc length in parametric form, remember now we got parametric equations. If a smooth curve C is given by x equal f of t and y is equal g of t, just like we had before, such that C does not intersect itself on the interval from A to B. Now that last example we did, it intersected itself. So to do arc length, you wouldn't be able to do anything down in this region because it intersected itself here. You could do something up here, you could do something over here, or you could do something in here, but you could not have any place where it intersected itself. So that's the difference of arc length. For derivatives, you can locate them anywhere. Okay? So arc length, as long as C does not intersect itself on the interval A less than T is less than B. Remember, T is your independent parameter. X is not, Y is not. They're both dependent on T, and they're not dependent on each other. Now, it says except possibly the endpoints. So, let's go back to this again. And it could have been anything coming down here as long as it stopped here, or even kept going here until it stopped here. Okay? There it does intercept itself at the endpoint, so that would be fine. Or even better, starting here and just going to there, those would be at the endpoints, both endpoints, or starting here and going anywhere up here, that would have been fine. But you couldn't start somewhere back here and end somewhere past that. That would be not allowed. Okay? So, the could intercept itself at possibly the endpoints. Then the arc length of C over the interval is given by S is equal to, now this is arc length, little s is arc length, remember, the integral from A to B, that's your limits on t. Remember, everything's t now. So this has to be a dt out here, not a dx, dt, because these are the limits for t. Now, before, if you remember, our arc length was the square root of 1 plus dy dt, dy dx squared. Not that anymore. It's dx dt squared plus dy dt squared, okay? Which, another way to express it, is the integral from a to b for t's of the square root of f prime of t, which is your x coordinate, or y prime of plus y prime of t, or g prime of t, which is your y coordinate, okay, squared. Each of those is squared. All right, so in my mind, a little bit easier arc length formula to remember, okay? Now, if a circle rolls along a line, then the point on its circumference will trace a path called a cycloid. Now, almost feels like we're going backwards here, because right at the end of the previous section, we did the totochrome and the batistochrome. Well, we actually did a cycloid then too. I thought we had. So they're going back and reminding you of this. If the circle rolls around the circumference of another circle, not along a straight line, then you have an epicyclone, okay? Cycloid, not cyclone. Epicycloid, okay? So a circle of radius 1 rolls around the circumference of a larger circle of radius 4, as shown in the figure. Then the epicycloid, traced by the point on the circumference of that smaller circle, by a point on the circumference of the smaller circle, would be, and it just depends on where you're starting. At t equals 0, you would start here, and then you're rolling this way, so this picks up and goes up to here, as that rolled. This amount here and that amount there are the same. Oh man, my head is clogging up on me. Sorry, just a moment here. I don't know if I need water or more caffeine or what. It's going to be tough sledding today, people. Sorry. Okay. All right. And it seems like y'all have scooted over some. Let me scoot you back. I think when we went to the new section, that happened. Okay. Man, folks, I'm losing it. I don't know if I only got one more class today. And 3 of you are in it, but one of them isn't here yet. No, all 3 of you are here. That's right. So y'all got to put up with this for 2 classes in a row. Sorry. Goodness. Hold on one minute. I think one thing that will help is if I turn on my ceiling fan. Because I'm getting very hot, and that's very uncomfortable. With the tiredness and everything else, that does not help at all. Okay. So, the circle of radius 1 rolls around the circumference, of a circle of radius 4, shown here. The epicycloid traced by the point on the circumference. Okay. So here's a circle here, and there's your point. So when this thing starts rolling around this way, that point is sort of picking up and going backwards, but you see the circle is moving this way, so it actually picks up and goes almost straight horizontally upward to this point, and then when that turns a little further, it has gone to here. Now right here somewhere, it would be right on the peak. Okay? Now, and when it rolls on back down here, it happens to stop right there. Okay? And then it continues around and goes through this loop and stops right there again, continues around here this way, stopping there, and continues around this way and stops there. That's an epicycloid. Okay. Now, the parametric equation for that epicycloid given by y is equal to 5 cosine t minus the cosine of 5t, and that's the x, y is equal to 5 sine t minus the sine of 5t. That's the trace of this epicycloid here. Kind of the four-leaf clover look here. Okay, but it doesn't go back to the center. Okay? Now, the question is, find the sorry. In addition to being tired, this weekend I was outside just about all weekend, mowing for Friday afternoon and basically almost all day Saturday, and then out working in our hardwoods for much of Sunday until it rained us out when we came in. So in between being around all the insects and all the pollen and everything else when I was mowing, then I got rained on a few times, so I don't know what's going on in my head now, but it's not pleasant. So if I start losing my voice, that's why. Okay, so oh man, these are your parametric equations. It says find the distance traveled by the point in one complete trip of the larger circle. Okay, now what you're going to be tracing a distance, that's how far this thing is moving here, 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 and here. In other words, the arc length. Okay, now rather than having to mess with these points where it makes these cusps, notice that the distance traveled here in this first quadrant is the same as the distance there, as there, as there. So we can just do from t is equal to 0, which is where we're starting there. Let's make sure that's right. When t is equal to 0, let's do our little table again. We're not going to do it quite as fully as they did last time. At t, x, and y, when t is equal to 0, this will be 5 times cosine of 0. Cosine of 0 is 1. 5 times 1 is 5. Okay, minus the cosine of 5 times 0 is 0. And cosine of 0 is 1. So 5 minus 1 is 4. So your x is at 4. And sure enough, right here, this is radius 4, 1, 2, 3, 4. That's where you start. Well, the x is right. Let's see if the y is right. When y t is equal to 0 here, sine of 0 is 0. 5 times 0 is 0. Sine of 0 is 0. So it's 0 minus 0 is 0. Sure enough, that's this point right here. So we are starting at the right point here. Okay? Now, let's go to another one. Let's go to t equal pi halves and see where we wind up. T is equal to pi halves. Cosine of pi halves is 0, and cosine of 5 halves pi is also 0, so that would be 0 here. And y is 5 times the sine of pi halves is 1, minus the sine of 5 times pi halves, 5 pi halves. Oh man. Let's think of this. Let's do us a circle here, if I can find some place to write the circle. Where are you, pen? There you are, somewhere there. Here we are. Okay. Now this is a unit circle now. This isn't either any of those circles there. Let's just imagine this is a circle. It doesn't have to be units, it's just a circle. There's 1/2 pi, 2 halves pi, 3 halves pi, 4 halves pi, 5 halves pi, which is what we have when pi t is equal to 5 halves. This is 5 halves pi. And where are you? You're right up here at pi halves. What is sine of pi halves? 1. So this will be 5 minus 1 is 4. Okay, now that wasn't particularly instructive on how you get there, except you know you went from this point 4, 0 to this point 0, 4. Yep, you had to have been following this route here. So if we can just make that, have our t going from 0 to pi halves, that's what we're after here, then we can do it. Okay, now let's remember what the arc length is. Where are you, pen? Come on, pen, show up somewhere here. There you are. Okay, the arc length is equal to the integral from 0 to pi halves. I say halves and write fourths. And you want 4 of these. Okay. The square root of dx dt squared plus dy dt squared. Okay. If I could find that pen. Oh, there it is. dx. Okay, folks, I am so sorry. I'm afraid it's going to be like this all day long. Sorry about this. For those of you who have the next hour too. In between, I'm going to get me more water. And meanwhile, I need something. I sure hope I can crash tonight. Okay. Because I got 4 classes tomorrow. One's a mini term with lab. So 8:30 to 5:45 with just very small breaks. All right. So that's what we've got. So our arc length then is going to be 4 times the interval from 0 to pi halves. Those are the limits on t times e. So what we've got to do now is get what the dx dt is. So let's do that here. Let's just call this x prime, if that's okay. That saves me having to write dx dt. This will be minus, I'm losing it, folks, minus 5 times the sine of t, okay, plus, because chain rule is going to have us a 5 here, the sine of 5t. Okay, now y prime, this is with respect to t, is going to be 5 times the cosine of t minus 5 times the cosine, if I could get this to right. This is so aggravating. This tablet will sometimes write when you want it to. It writes when you don't want it to and doesn't when you do. There we go again. Yuck. Okay, if I can get that S good form here. 5 times the sine, that time it took it. Sine of 5t. Okay. No, cosine 5t. Alright, let me go back. Like I say, folks, I'm losing it badly. But at least I can erase. Well, that erased way more than I intended for it to. But let's see if we can get that back. It decided to erase way more. I didn't come anywhere close to that stuff. Okay. Minus 5 times the cosine of t minus, or plus, wait. I'm getting so confused now. It's positive 5 times the cosine of t. The brain's not working. Sorry, folks. Now something just made a noise. I don't know what that noise was. and this is going to be a minus. Okay. Five times the cosine of 5t, and that's what we've got there. Okay, goodness gracious. So we've got our primes there. Now we've got to square those things, okay? And then take the square root of the sums of those. So this is going to get a little messy, but I think we can do it. 4 times the integral from 0 to pi halves, I believe that was, if I can, yeah, 0 to pi halves, okay? And it's the square root of, come on, the pen just disappears on me sometimes. Here we go. The square root of, now let's do, I wish I could just set this down, but it starts typing things I don't want it to type. We've got to square this x prime, okay? Now what I think I'm going to do, notice, sorry. Let's factor out the 5. In fact, for the x prime, I'd say factor out a minus 5. And then square what's left. And we're going to square the 5 too, or the minus 5, and square what's left. That may be, let's just work it out, because I'm afraid I'll lose you somehow there. So let's square this. The square of this is 25 sine squared t. Okay? Plus twice the product of these two. Okay? That's going to be minus 20 sine t sine 5t. Okay, that's the middle term. It's twice the product of those. No, it's minus 50. Yuck. The brain is not working today. It's too tired. That's the 50. Because the product of those two is a 25, and double that, you get 50. And square the last one, you're going to get plus 25 sine 5t squared. Okay, and we're only halfway there. This is all under the radical. So let's do the square of dy dt. That's this thing. Come on, where are you? The pen just vanishes. There it goes. Okay, so let's do, this is also under radical, and that would be 25 cosine squared t minus 50 times cosine t cosine 5t plus 25 cosine squared 5t. And then we have our dt. All that's under the radical. The good news here, folks, is sine squared t plus cosine squared t is 1. So that's going to be, let's simplify that radical. In fact, I guess I should write it all down again. So your s is going to be 4 times the integral from 0 to pi halves. Excuse me again. Goodness gracious. I'm going so on top of everything. Of course, right before this, I crammed down about 2/3 of my lunch as fast as I could. That's one reason I'm thirsty. But the other thing is now that, in addition to all the tiredness, now my stomach is demanding the blood to help it digest the food, so I'm losing it any further there. So I don't know. Sorry about this. All this sad story. Okay. So when you add this one and that one, basically you get the square root of 25. Okay, because sine squared t plus cosine squared t is 1. Okay, now notice, well, let's do this one too. 25 times sine squared t plus cosine, sine squared 5t plus cosine squared 5t, that's also 1. So that's another plus 25. Okay. Now, the middle terms are both minuses, and they're both got 50s in them, and that's going to be 50 sine t, sine 5t, cosine 5t. Sine t, cosine t, sine 5t, cosine 5t. Okay. And that's all under the radical. Okay. These add to 50, and that has a 50 in it, so we can factor out a 50 under the radical, but 50 is 25 times 2, so that's factoring out a 5 root 2. So I'm going to come down here, only place left I got to write on the board here. S is equal to 4 times the integral from 0 to pi halves of 5 root 2, that's what we factored out of that, times the radical. What do we have left in it? 1 minus sine t cosine t sine 5t cosine 5t. Now, I have a feeling this is not the easy way to do the problem. And then we have our dt here that I probably haven't been writing in when I needed to. I'm sorry. These should be pluses in between these. This is 50 times this. Right here, 50 cosine t and plus, these are added to each other, not multiplied by each other. So I pulled out the 50, but forgot to put my plus in here and my plus in here. Well, that was in the wrong place, this one. So this is getting messy. And I got them grouped badly. So this is the square root of 1 minus sine t sine 5t minus cosine t cosine 5t. I think. Okay, with this 5 root 2 out front and the dt over here. I left off my sign in between, sorry. 4 times the integral from 0 to pi halves of that. Now, again, that's really, really messy, okay? except for what they say the difference formula for cosine. Okay, now where I point you to for this is go back to the inside cover of your text, that first page inside your text, inside the front cover of your text. It's a cardstock type page. Now if you got an e-text, I assume it's just part of the pages there. First thing inside the cover, the first side says derivatives and integrals, 36 basic differentiation rules, 20 basic integration formulas. Don't worry about that. Flip that page once over and then you got a trigonometry page. Okay, and what we're looking for here is the difference formula for cosine. Okay, now go to the bottom left column of that and you see your sum and difference formulas. And this is cosine of u plus or minus v is cosine u cosine v minus sine u sine v, or minus plus. We have a plus in there, okay? Because if you factor that out, these two, factor out the minus 1 here, put a plus in there, and unfortunately I'm running out of room at the bottom of the sheet here, and this is going to be the square root of 1 minus, okay, and that's going to be with the plus sign there, that's cosine of u minus v, cosine of t minus 5t, which is a minus 4t, but guess what, cosine is an even function, so that's what your integral turns out being. Now I'm running out of room fast, okay, so let's just go to their rendition of this. This is not a particularly easy problem, as you can tell. Their rendition of this, and pick up there, okay. Now it says, before applying theorem 10.8, note that in the figure that the curve has sharp points, we often call them cusp, when t is equal to 0 and t is equal to pi halves. We already noticed that. And we saw that the arc length that you went from 0 to pi halves is repeated 4 times. Because those 2 points, dx dt and dy dt, are not simultaneously, or between those 2 points, they're not simultaneously 0, but at the points they are. So we can't use that there, but we can do it between the two. So the portion between t equals 0 and t equals pi halves is smooth. As long as that's smooth, we can apply the arc length formula. Remember, it doesn't work when those are not smooth, when your derivatives are not simultaneously 0. To find the total distance traveled, you can find the arc length of that portion lying in the first quadrant, multiply it by 4. That's what we were in the process of doing. So here's the formula I had written down. S is equal to 4 times the integral from 0 to pi halves of the square root of dx dt squared plus dy dt squared dt. Okay? Now, we, just like we did before, we took 4 times the integral from 0 to pi halves. Now this one was minus 5 sine t plus 5 sine 5t squared. That's what that was. Plus 5 cosine minus 5 cosine 5t squared dt. Okay, I hate to do this again, folks, but I am sinking fast. Excuse me. Sorry to do this in class. I'm feeling about as rotten as I've felt in a long time, and I'm so sorry about that. Okay. I'm not quite as hot as I was, but I'm feeling, It's just worn down, I think. Okay. Now, that's exactly what we got, those squares. This was the derivative of x dx dt, and then you square it, and this is the derivative of dy dt. Square it. Okay. Now, I think they skip a bunch of steps. Yes, they do. Don't they ever skip a lot of steps. And this is sort of what I was getting at. And I thought I was skipping steps. Okay, when you square this, every which way you do it, if you factor the 5, the square root of 5 out of this, or square root of 5 squared out, that would have left you a 5 on the outside of the radical, okay? Because every term has that in it, okay? So that's where the 20 comes from, okay? Sorry, I was trying to show more of this detail there, leaving it out. Okay, if you factored that out, let's see what you'd have left. Sine squared t from here, cosine squared t from there, that gave you a 1. You had factored out the 5's already. Sine squared 5t plus cosine squared 5t. Now this would be a plus here because when you square this, you have this term squared, twice the product of those, that would be a minus, but this one would be this thing by itself, which would then be a plus cosine 5t squared. So that gave you another 1. So that's where this 2 came from. Okay. Now remember, you factored out the 5's. In the middle term you have minus 2 sine t sine 5t. That's where this one comes from. And this one, the middle term, would have been, because we're already taking care of the outer terms, inner, first and last, the middle term would have been minus 2 times the cosine t cosine 5t. All right. Now, this is where the magic comes from, okay? And they just say the difference formula for cosine. And that's the one I pointed you to at the back, at the front of the book. If I can get it again, I'll read it out to you and see if this comes the same. This would be since this is a minus, okay, the 2's out there by itself, and this is minus a 2 sine t sine 5t plus, if you factor the 2 out, plus let's see, yeah, 2 cosine t cosine 5t, that would be, and there's a plus in between there, so it really doesn't matter, cosine of u minus v. Let the u be 5t, the v be t, and that gives you cosine of 4t. So that's where that comes from. The minus 2 stays with it because remember that minus was out in front anyway. Okay, so that gives you that form. Okay, now we need to integrate this one. Okay, now looks like possibly a u substitution has some promise, except for the fact you don't have a sign on the outside and you needed that for a u substitution. So we've got to deal with something else here. Okay, and that then is the double angle formula. So go back to that same inside front cover of the text under the trigonometry. Now go to the right hand column above midway down the page, and you see the double angle formula for, and there's one of two kinds here, one of three kinds for cosine 2u, okay? And that would be the middle one. The cosine 2u is equal to, I'm going to write this down from your cover if I can get the pen to show up. Where are you, pen? Oh, I'm on the wrong pad. That's why it's not showing up. Okay, there's the pen. Okay, I'm going to write this one down. The cosine of 2u is equal to, I'm going to do the middle one here, 2 times the cosine squared u minus 1. Okay, now that doesn't look too much like what we've got here, unless we do some fiddling with it. Okay, okay. And I'm not quite sure how I see they did this. Make sure I copied that one right. Two cosine squared u minus 1. Yeah. Okay. Yeah. Okay. Let's solve this for cosine squared. Okay. And this would produce 2 times cosine squared u is equal to 1 plus cosine 2u. Okay. So, and this is what I was trying to do before. I ran out of room before, I'm going to run out of room again. Make this 20, and they take out the root 2 here. I think that makes everything easier, that root 2 right there. And then this gives you 0 to pi halves. Okay. Now what we have here is the square root of 1 minus cosine 4t dt. Now, up here we have 1 plus. And that's the part I'm having trouble seeing how they finesse their way around. And all they say is use a different, or the double angle formula. That's because I used the wrong one. Sorry about that. Let's go back and use the right one. Okay. Okay. Cosine 2u is equal to 1 minus sine of 2 squared u. Okay. Okay. Yeah, there's 3 of them. I picked the wrong one. 1 minus two sine squared u. Okay, that's the one we need. Okay, now we'll do the same thing I tried to do before, and this will be 2 times the sine squared of u. That's this term. I moved it over here. Subtract this one there, you get 1 minus cosine 2u. That's what we want. Okay, now what this produces is, I'm going to try to write it here, here's my 20 root t here, root 2 here. The integral from 0 to pi halves. Now, sorry. Let's make this 4t 2u. Okay, sorry about that. So u is equal to 2t. Okay, and then this will work fine. This will be cosine 2u, but your dt, 2 dt. We don't have a 2 dt, so let's divide everything by 2. Okay, now what that's going to do is drop this to being a 10 here. I know this is too many moving parts. Okay, and so what we have then is the square root of 1 minus cosine 4t here. Okay, and that becomes 2 times sine squared of 2t. So we move the 2 back out here, and it goes back to being 20 again. Sorry about that. And then you have, I'm sorry, it's another square root of 2. So this is a total 20 now. Sorry about that. This is the square root of, we pulled the square root of 2 out and left us a sine squared, which is just going to be sine 2t dt. And you can do a u substitution or whatever there, and you get this was sine squared, lose the square root sign, and you get minus the cosine of 2t over 2. And then that 2 divides into this and goes back to 10 again, 10 root 2. And evaluate that from 0 to pi halves. Oh man. And when you do that, 2 times pi halves will be pi. Cosine of pi is minus 1. You got a minus in front, so that's going to be a 1 here, and then minus a minus, which is plus, so you get another 1 there. So 2 times that, and that goes back, I think, to being 20. I'm sorry, 40. I'm sorry, it was a 20, and 2 times that is 40. They skipped steps like crazy. I'm going to erase all that I have here, and I can do that now. I didn't think I could before, but I'm going to erase all the ink on the slide. Okay, and they take this down to, and they use a double angle formula to get that, and they factor out a 2. That's where the 40 came from. And then the antiderivative of that would be cosine 2t over 2, and so the dividing by 2 divided that again, and cosine of pi halves is minus 1. Well, 2 times pi halves is pi. Cosine of pi is minus 1, and then minus the cosine of 0 is 1, so that's going to be a minus 2 in here times the minus 20 out here is a plus 40. And that's where you get that. My goodness, what a long, convoluted problem. Okay. The circumference of that circle of radius 4, no, radius 6, and that would be, let me show you that on their figure. They may go this. Let me see if they do it first, so I won't have to do that. Yeah, okay. Now, this one here has a radius of 4. You're rolling this around, and at most, and this has a radius of 1, but that would mean a diameter of 2. So if you had a circle of radius 6 out here, that would just go around here, hitting the high spots, okay? Now, that's a shorter path by a little bit than going down and touching here. This is just a smooth arc here. This is a little bit more. So these are going to be a little bit longer. Well, what would be the radius of 2 pi? The circumference of pi 6. Circumference is equal to 2 pi r, and if r was 6, then this would be 12 pi, and 12 pi, pulling out my calculator here, I almost knocked over my glass, but fortunately it was empty. I'm not quite charged yet. And getting my calculator to come up. Well, it didn't come up. Okay. And turning it sideways to get it scientific mode, 2 pi times 12, or I mean 12 pi, that's 12 times pi, pi key here, that's around 37.7. That's what they said, and we said 40. That certainly seems reasonable. Okay, so use every tool in your tool belt to try to check and verify that you've got things right. Okay, boy, what a convoluted problem. Now, next thing we're going to do, and I think my wife's home, so I'm going to have to close the door behind me. Hold on just a minute. She had to. Okay, this is not quite going to be long enough. Okay, pause just a moment here and make sure that was her. Okay, I'm back mostly. Oh man. Let's move on to the area of a surface of revolution. Okay. Excuse me. What we're going to do now, we're going to use the formula for the area of a surface of revolution in a rectangular form to develop a formula for a surface area in parametric form. Now, if you recall, I don't know if you do or not, basically what you have is an arc length, just like we were just doing, whatever that formula is, which basically looks just like this part right here. Okay? Now, that's an arc length, and a surface of revolution is then going to be take that arc length and go all the way around whatever axis you're doing. Now, if you're doing the x-axis, goodness, my nose is itching, then your radius is going to be your g of t, your y. If you're doing around the x-axis, your radius is going to be the x, which is f of t. So 2 pi times the radius times your arc length. That gives you your area of surface of revolution. Capital S is a surface area, little s is an arc length, so don't get those confused. So this is revolution about the x-axis, 2 pi times the y value, because you're going around the x-axis, whereas if you're going around the y-axis, it's 2 times the x value, which is the x value is f of t. But get everything in terms of t, and there you have it. X is f of t, y is g of t, and your arc lengths are the square root of dx dt squared plus dy dt squared, exactly the same in either case. Okay, so that's what we use. It's a fairly straightforward dealing with it, as long as you don't have a real convoluted arc length like we did with the epic cycloid. That was convoluted. Let's see if they give us one a little easier. So these formulas are easy to remember. If you think of the differential of the arc length as being this, that's what I was trying to say, and then 2 pi times g of t times that ds, that would be the surface area around that, and this would be around the x-axis, and this would be around the y-axis, where f of t is your x, g of t is your y. Okay, so here's example 5, the last example in the section. How are we doing on time? We go to 55, so we got about 15 minutes. I think we should be able to do this one fairly easily. Let C be the arc of the circle. X squared plus y squared is equal to 9. From 3, 0, that certainly is on the circle, up to 3 halves, comma, 3 root 2, 3 over 2. Okay, I'm a little skeptical here, so let's just check and make sure this point is on that circle. So that would be x squared would be 9 fourths, because that's your x, right? Square that, you get 9 over 4, plus, and the y squared would be 9 over 4, but then times square root of 2 times square root of 3, that would be 3. Okay, what do we have here? Okay, let's factor out 9 over 4, and what do we have left? 1 plus 3. 1 plus 3 is 4. 4 times 4, 4 and 4 cancel out, that leaves you 9. So yes, that point is on the circle too. I knew it was, but just one way to check. Make sure you don't have an ill-posed problem and try to solve a problem that can't be solved. Okay, so here's what we're doing. There's the arc from 3, 0 up to that point there. Find the area of the surface formed by revolving that curve from 3, 0 up to here around the x-axis. Okay, now obviously the first thing we've got to do is come up some parametric equations here. Okay, now what would they be? Your x as a function of t is going to need to be actually, rather than t, I would say let the parameter be theta. And you're going basically from 0 to, if you think of this, this would be this angle here. Oops, I can't draw very well. This is not drawing well at all. Okay, that angle here, wherever I have it there, is pi thirds, wouldn't you say? Because the cosine of pi thirds is 1/2, and the sine of pi thirds is root 3 over 2, and you have a radius of 3, so just multiply that by it. So that's what your angle theta should be. Okay, and they already told you this is a circle, so x is equal to cosine theta, and y is equal to sine theta. And that should work, shouldn't it? Because cosine of theta here would be 1. Okay, I'm sorry. 3 cosine theta and 3 sine theta, because you're out here at 3. When theta is equal to 0, you're at 1. 3 times 1 is 3, and sine is 0. Okay, and when you're up here at theta equal pi thirds, cosine of pi thirds is 1/2. 3 times 1/2 is 3/2, and sine of pi thirds is root 3 over 2 times 3 is 3 root 2. Yeah, that should do it. Okay, so those are your parametric equations. All right, your surface area then, capital S, would be, now flick back just to remember, is 2 pi times your g of t and your f of t. These are your g of, this is your f of t, f of theta in this case. Where in the world is my pen? There it is. This is your f of theta, and this is your g of theta, just to remind yourself. Okay, now the surface area would be 2 pi times the integral of, okay, remember, your f, and this is revolving around the x-axis, so your radius is the y value, okay, the g of theta in our case, and then we're going to square both of those, so we'll get to that in a minute. Okay, so this is going to be your g of s. Okay, what is your y value? It's this one right here, 3 sine theta. Okay, I'm going to take the 3 on the outside and make this 6 pi sine theta times the square root of, and we have to take our derivatives of each of these. Your x bar is going to, x prime is going to be minus 3 sine theta, and your y bar, y prime, is going to be 3 cosine theta. And that's what you're squaring under here. So you're going to have a 3 squared and a 3 squared, and that'll be a 9 and a 9. Factor that out. So this will be square root of 9 is 3. So this gets us up to 18 pi, because you're squaring the 3, which will be 9, but factoring it out of a square root, and that'll be square root of that would be 18. Okay, sorry. And then what's left here is sine squared theta plus cosine squared theta. And I don't know what this here is. That's not in the picture at all. Okay. And that's just going to be 1. So square root of 1 is 1 d theta. Okay, now this is looking awfully simple. Let's see if that's true. S is equal to 18 pi. Oh, and this is going from 0 to pi thirds. That's what theta is going to. And the antiderivative of sine is minus cosine theta from 0 to pi thirds. Cosine of pi thirds, we've just been talking about it, is 1/2. So that's going to be, goodness gracious, where is it? Here it is. 18 pi times minus 1/2 minus a minus, which will be a plus 1. So that's going to be plus 1/2. So that looks like it's going to be 9/2. Let's see. Oh, I mean 9 pi. I say 9/2. I wrote it right. 9 pi. And that is indeed what your area is. So that's how we did it. Let's see how they did it. You can represent C parametrically by the equation x is equal to 3 cosine t, y is equal to 3 sine t. Okay, just like we did, and the t is going from 0 to pi thirds, okay, just like we did. Note you can determine the interval for t by observing that sine, when t is equal to 0, x equal 3, and t is equal to pi thirds, x is equal to 3 halves, 3 times 1 half, and that gives you exactly your limits, okay? Now, on that interval, c is smooth, y is non-negative. You can apply the theorem about arc length and stuff, so and surface area. So it's 2 pi times the interval from 0 to pi thirds. That's your t interval here, right here, 0 to pi thirds. Here was your 3 sine t. That was your y value. Remember, y is 3 sine t. So there that is. I did take that 3 out and make it a 6 pi here. Okay? And just left the sine t. They'll do that later. Well, if they've done it. Okay? And square root of this, and that would be a 9 on the outside, sine squared t plus cosine squared t. Square root of 9 is 3, so that 3 goes out and makes that a 18 pi. And then you got sine of the integral of sine t dt, because the rest of that's 1, and that gives you, well, they left that in there. I would have pulled it out and made it, I did, 18 pi integral from 0 to pi thirds, and that gives you, there's the minus 18, and the minus comes from the antiderivative of sine is minus cosine. Then you evaluate that, and that would be a 1/2 minus 1. It gives you a minus 1/2 times a minus 18, and that gives you a plus 9 pi. All right, I think that's the end of the section. Thank goodness. I'm sorry. Okay. Homework exercises here now. I've said this a few times before. I'm going to try to say it every time. When we finish a section like this, that concept check at the top, there's 4 things here reminding you of the things you're supposed to remember from this section. Good thing to look at, good thing to review. Homework exercises here would be 5 or 7. They're both at Calc Chat. 5's at Calc View. Any of the odds 9 through 17, they're all at Calc Chat. 13's at Calc View. 19 or 21, they're both at Calc Chat. 19's at Calc View. Any 23 or 25, they're both at Calc Chat. 27 or 29, they're both at Calc Chat. 29's at Calc View. 31's at Calc Chat. Any of the odds 33 to 41, they're all at Calc Chat. 35's at Calc View. 43 to 47, they're all at Calc Chat. 43's at Calc View. 49 to 53, they're all at Calc Chat. 51's at Calc View. 55 or 57, they're both at Calc Chat. 59 or 61, they're both at Calc Chat. They say you may need a graphing utility, at least for part of the problem. See if you can get it. And by the way, you'll see a potential paper topic or two in the folium of Descartes. What in the world's a folium, or how did Descartes come up with it, or who was Descartes? Several things there. The Witch of Agnesi, which is a really bad mistranslation of the Italian, I believe it was. It should have been the Curve of Agnesi, but since Agnesi was a woman, they let the mistranslation stand and called it the Witch of Agnesi, which is very sexist. But that should be at 62, which you don't have to do. But who in the world was Agnesi may be a great paper topic. Very incredibly bright mathematician back when women weren't even supposed to learn anything. Okay. Any of the odds 63 to 67, they're all at Calc Chat. 65's at Calc View. Either 69 or 71, they're both at Calc Chat. You may need a graphing utility for some of that, but hopefully not. 73 or 75 you can explore doing if you're interested. That's up to you. They should be at Calc Chat, or at least parts of them should be there. 77 should be at Calc Chat. 79 should be at Calc Chat. 81 and or 83 should be at Calc Chat. I'm sorry. Any of the odds 81 through 85 should be at Calc Chat. 87 should be at Calc Chat. 89 should be at Calc Chat. Any of the odds 91 through 95 should be at Calc Chat. And then finally, there's two true false, 97 and 99. They should both be at Calc Chat. All right, that takes us right up to 10-4. How much time do we have? Oh, man, we're right on exit time. So we're going to discard this, and we'll pick up next time at 10-4. Any questions on 10-3? Now, again, I remind you, 10-4 is the last section we're going to do, and if we can't finish it next time because it is got some complication to it, we definitely will finish it next Monday, knock on wood. Okay, so that means I'll try to have your test ready for you on Wednesday if I can. Now, I don't have much opportunity. I doubt if I'm going to have it ready by Wednesday, and here's why. We've got to go up to Jasper, Alabama Wednesday afternoon after class, so I doubt if I'm going to have time to make out the test that afternoon. So it'll probably be over the weekend sometime, but I'll put out the test just as soon as I can. What that means for you is I'd love to have your first test in. Some of you have turned it in, but some of you have not. Please have that in to me before I put this next test out there, which will be sometime not possibly even this weekend. So try to get your test into me today, tomorrow, Wednesday, Thursday, Friday, anytime like that. I'll be putting out the test when I can, possibly as early as Friday. Okay, so try to get me your test in. Now, if you have any questions, ask those first. Okay, we'll be in class Wednesday. Ask those first, so we can clear those up so you can get the test completed by the weekend. Okay, any questions? Okay, I can't tell if any of you are still there, but I'm going to stop the sharing here. That left us with 5 students. I guess we lost Laron because we had 6, but hopefully he was able to hear most of it. And if you don't have any questions, I will end the meeting now. Goodness gracious, I'm tired. Okay, we'll see you on Wednesday. Hopefully, I'll be somewhat rested by then. Take care. See you Wednesday. Bye-bye.